Hello everyone, welcome to my YouTube channel Programming with DPwala. Hope you all are doing good. Today we are doing post analysis of contest Codechef Starter 62 and we are discussing the problem Pythagorean pair. The difficulty rating of this problem is 1862. The problem was quite easy to understand. Only the difficult part and the challenging part in this problem is its constraints. As the problem is not that much difficult, but the constraint makes it quite difficult in implementing. So let's discuss this problem. In this problem, we need to find the pair, or we can say two numbers a and b, whose square of the sum of them square is equivalent to n. And if no such pair exists, we need to print minus one. If it exists, we need to print both a and b. Let's discuss. Here, the constant that were given are from 1 to 10 to the power 15. Means it is quite large from 10 to the power 8. So we can't run the loop from 1 to n, or we can say 0 1 to n plus 1, or we can say 0 to n, because otherwise it will give time limit exceed error. So the brute force approach that comes to our mind is we can run the for loop from the 1 to the square root of n and apply the two pointer approach and find the two pairs and print that. But this will not work because here some of the test cases were designed such like that it will give, or we can say it will generate the very large number as we are multiplying the two numbers a into b, as we are calculating the square. So it will generate the very large number, which will may give a overflow condition, or we can say overflow error. So here we, to solve this problem, one must be familiar with some of the bit manipulation techniques such as left shift operator and the right shift operator, and the two pointer technique, or we can just slide, or this problem can be also be done using sliding window and binary search technique. So here I have used the bit manipulation plus two pointer technique. So let's discuss this here. As we we can't run loop from 1 to n, we need to run the loop from 1 to square root of n, as we are using two pointer. So we need to consider the two pointer. One, the starting pointer is at the starting index number, that is 1, and the ending pointer is at the last number, that is square root of n. Here I have taken the input, and the base, for to solve this problem we need to consider the two base cases. So here this is the most required base cases, otherwise the question will give TLE. This is the hidden case that we need to consider. We need to shorten the number into the smaller one and apply the two pointer technique on that range only. So here uh, we will shorten the number till the number is not divisible by 4. If we have maintained the counter variable, that is count, we check whether the number is divisible by 4 or not. If it is divisible by 4, we increment the counter and we divide the number by 4 and we shorten the number. And after shortening the number and at the condition when the number is not divisible by 4, we come out of this while loop and we get the smaller number, that is n, which is now not only the actual n, it is the smaller n. We can say the number is now got shortened, and now we apply the two pointer on this range, means 0 to square root of n, as the square root of n is not that much large and it is in the range of below 10 to the power 8. And here we have taken the two variable a and b, as we need to print variable a and b, and we apply the two pointer technique, as left is left less than equal to right, and check, and we have here we have calculated the answer, means as our number is left is equal to 0 and right is square root of n. So we check this condition, a into a plus b into b. Here we have done the same thing. If this answer is equivalent to n, then we got the two numbers a and b. But as we know that as we have shortened the number from n to some small value, so this a and b is not actual a left into left and right into right. We need to perform the left shift operator here, as we have counted the number of times we have divided the number by 4. That time only we need to perform the left shift operator of that a and b. Here we have done that only. If the number is not, if we do not get any number, we simply perform the operation. If the number is answer variable is greater than n, we decrement the largest pointer, means the right pointer. Otherwise, we if the number is smaller than n, we simply increment the starting pointer. And at last we check whether the number we got a and b or not. After performing two pointer, if we do not get any value, the a value is still -1, so we will simply print -1. If we got the pair, then we simply print a and b. Let's dry run this for the some of the cases. Let's take n equal to 100. Here we have done the operation for the 100. Let's take 100. 100 modulo 4 is equivalent to 0, right? So we increment the counter. Now our counter becomes 1, right? Now our counter becomes 1 and our number becomes 100 divided by 4, that is 25. Now we check whether the 25 is divisible by 4. No. Now this is our condition when this will come out of our loop. Now our n becomes 25. Now our n becomes 5, not 25, 5. Here our two variables are a and b, that is -1 and -1. Now as our number is 25, square root of 25 is 5. Now our range is from 0 to 5, including 5 and including 0. And we have performed the operation of two pointer approach on that. And we calculate. Let's take as our left pointer is 0 and right is 5. We perform the operation. We multiply 0 into 0 plus 5 into 5, right into right. We get 25 and our actual number is 25. So what we can do, we will check whether 25 is equivalent to 25. Yes, it is equivalent. Now we got the two numbers a and b, but it is not the actual a and b. A is not right and b is not left. We need to do left shift operator. As our count is 1, so left shift operator is nothing but power of 2 to the power count. Means left, it is 0 into 2 to the power 1 and it is 5 into 2 to the power 1. 0 into 2 to the power 1 is nothing but 0 and 5 into 2 to the power 1 is nothing but 10. So our a and b is nothing but a equal to 0 and b equal to 5 into 2, which is equal to 10. And we get the corresponding answer, that is 0 and 10. This is our approach for solving this problem. And here we can see that there are the four test cases that they have given: 100, 6, 13 and 4, and answer is 8 and 6. As we know that there can be multiple pairs that can be exist. It can be 0, 10, it can be 8, 6. Anything can be the answer. So there are multiple test answers possible for the number n. This is our approach for solving this problem. If you apply two pointer approach simply on this without using the bit manipulation, it will give TLE, or we can say wrong answer, as the number is quite large. We need to apply this. Hope this video is helpful to understanding this problem, Pythagorean pair. Hope you like this video. Please like, share and subscribe this channel and stay connected for every code chef, code forces and lead code contest analysis. Thank you.